All right, we are going to work on our similar triangles notes today. These are at the bottom of page 12. We've already filled in the top of this page. So bottom half of page 12. Triangles are polygons, so in order for them to be similar, the triangles would need all of their angles to be the same and their sides to be proportional. But we have some other ways to show that triangles are similar without having to show all of the angles or all of the sides, just kind of like how we had some congruency theorems, we have some similarity theorems. So the most common one is the angle-angle similarity postulate, which means as long as you have two congruent angles, you can find a third one. Okay, we know they add to 180, so these third angles would all have to be the same. And if all the angles are the same in a triangle, then they are similar. The other one is side, 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 but instead of them being congruent, they're proportional. So if you have three sets of proportional sides, then you can say they're similar. And then in turn, you can say that all of their angles are congruent. And then the last one, side angle side similarity, when you have two proportional sides on either side of your angle. So that would have to be XZ and MP are proportional, XY and MN are proportional. So, oh, that's not what I want. Here, XZ over MP is equal to XY over MN. And this angle is congruent in the middle. Determine if the triangles are similar by angle, angle. If they are, write a similarity statement. If not, explain why. Here we have a 90 and a 35. So if I take that away from 180, we get 55 here. And then here we'd have 30. So we'd say no. Not similar. 77 and 48 would make the missing one 55. So 55, 48, and 77. So we'd say yes, they are similar. So let's say triangle ABC is similar to triangle. You'd have AEF, or I'm sorry, DEF, because you have to put them in the same order. So if we went 77, 48, 55, we'd have DEF. All right, if we have parallel lines, that means you know that these two angles are congruent. You also know that these are congruent. And then you know that these in the middle are congruent because they're vertical angles. So we can say yes, they are similar. And we'll do triangle XYW is congruent to ZYB. I'm sorry, I should put them next to each other like this. There you go. Okay. For this last one, D, we know that angle W has to be the exact same in both triangles because they are contained inside of each other. And then that means that your last angle has to be the same also. So we can say yes, they are similar. So triangle VWX is similar to triangle ZWY. And order does matter for the second one. You have to match it up to the first one. Determine which two of the three triangles are similar. Find the scale factor. So these angle measurements aren't really going to help us because we need to know all three and they only gave us one. So we need to know at least two. But we can look at the sides. So let's say if we do 5 over 4 equals 8 over 7. If I cross multiply, I get 35 equals 40. Okay, so those do not go together. Let's do these two. So 4 over 2 equals 7 over 3.5. So you have 14 equals 14. So these two triangles are similar. So triangle DEF is similar to triangle GHI. And your scale factor, which we often use K for, would be 1/2 because we're getting smaller there if we go in this order. 1/2. Okay, same thing for B. Let's do 24/18 equals 16/12. So 288 equals 288. Okay, so we've already found the two. It's these two. So we'll say triangle ABC is similar to triangle DEF. And their scale factor is 18/24. And we can simplify that to 3/4. The triangles are similar. Find the value of the variable. So let's use something that we know. Since these are parallel, I'm going to go ahead and label your opposite interior angles or alternate interior angles so that it'll help us decide what to pair with what. We need to include 2 and 3 because that's known for us on both triangles. So let's do 2/3 equals 2/3 equals y/7. So then we have 14 equals 3y. And 3y like that. And if I divide by 3, then I'll have 4 2/3 or 4.6 repeating, anything like that. So now let's try to find x. We have 2/3 equals x/5. So you have 10 equals 3x. So you're going to have 3 1/3 or 3.3 repeating equals x. Okay, part B. Here we have 18/24, that's known, equals y minus 3/32. And don't forget, you have to distribute this 24. So it looks like 27 would be our final answer for y. All right, next page. Okay, by what method, if any, are the triangles similar? So since these are isosceles, we know that their other side lengths are congruent. And then we have to make sure they're proportional. So we should have 4/6. We need that to be equal to 6/9. So you get 36 equals 36. That checks out. So yes, similar by side, 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 side. There we go. And if I take 180 minus 92 and 57, I get 31, which means these are not going to be the same. This missing angle is 47. They're still not the same, so they are not similar. For C, we have isosceles triangles. So if this is 30, then these two angles have to be the same. So if you have 30, that means you have 150 left, so they're each 75. So 75, 75, and that's going to be the same on this one because it's isosceles. 75 and 75. So yes, similar by angle, angle. Use the diagram to complete the statements. So triangle ABC is similar to triangle ABC would be DEF. Angle B is congruent to angle E. Okay, we've got to find x and y. So if I use 6 over 16, then I can use x over 12. So we get 72 equals 16x. That would be 4.5. And then I'm still going to use 6 over 16 equals 8 over y. So you have 6y equals 128. So y is 21.3 repeating. AB over DE equals BC over EF, CA over FD. Blank over 12, so I think that's x over 12, or in our case, let's use 4.5, equals 8 over y, which we found to be 21.3. You are standing 18 meters from building A and 15 meters from building B. Okay, let's say, got some distances here. This is building A and building B. You are 15 meters from A and 50 from B. So this is not drawn to scale, but we're just trying to get an idea. Building A is 90 meters tall. Find the height of building B. Okay, and we're going to assume that this is similar. So if I have 15 over 50, then I have 15 over 50 is 90 over x. Two zeros there. 300 meters tall. To determine the height of a very tall pine tree, you place a mirror on the ground and stand where you can see the top of the tree. How tall is the tree? Okay, so you have 2 over 6, we'll say, equals 24 over our variable. So 144 makes x 72 feet. All right, your assignment for today are pages 27 and 29.